independent sample t-test. So as we call it independent samples, so here we are having two different samples. There we are having two different samples, and these two samples are assumed to be independent. The mean of first sample is x1 bar, the mean of second sample is x2 bar, right? So we are having two different samples, and the null hypothesis here is the mean of sample 1, which belongs to the some population minus or equal to the mean of sample 2. So here we assume that the sample mean of one sample is equal to the mean of second sample, right? So this is our null hypothesis. Now in this case, there are two steps. If you want to apply independent sample t-test, so there are two steps, steps 1 and we are having the step 2. So in step 1, we examine the assumption, and in step number 2, we apply the t-test. So you have to be very, very careful that whenever we are going to apply independent sample t-test, the assumption testing come first, and then we go to t-test. So let me explain you in next slide. So the assumption, what is the assumption? So the assumption is the variance of sample 1 is equal to variance of sample 2, and this test is known as Levin test, and this test is basically known as the homogeneity of variance. Homogeneity means equal. This is the homogeneity of variance, and this is the most important assumption in independent sample t-test. Now what happens, this assumption may fulfill, this assumption may not fulfill, this assumption may be fulfilled, and this assumption may not be fulfilled, right? So if this assumption is fulfilled, we assume that we are applying the test on the large samples, and if it is not fulfilled, we assume that we are applying the test on the small samples, right? So as I told you that if a variance of two different samples are equal, it means your samples size are large. If this condition is not fulfilled, it means your sample size is small. So whether the sample is large or the small depends upon this condition. In books, it is mentioned that if the sample size is less than 30 or more than 30, you can consider is large or not large. But in most of the research, they are not following this condition. They are following the condition, the condition of Levin test. If Levin test is fulfilled, then we can say the sample is large. And if the Levin test is not fulfilled, then we assume that the sample are small. So if the sample is large, we will consider the formula like x bar minus x2 bar upon combined standard deviation upon the combined n1 plus n2 minus 2. But in this case, the formula above formula is different. Formula of 2 is different, because here this is not equal to the variance of sample 1 is not equal to variance of sample 2. So we have to calculate the combined standard deviation of the samples. So we calculate the combined standard deviation of the samples. So the formula is different, right? So this is the condition of applying independent sample t-test. First, we have to check the assumption. If assumption is fulfilled, then we go to this formula. If condition is not fulfilled, it means we are applying this test on the small samples. In this case, the formula will be different. Okay, so now I'm explaining this concept with the help of one example so that you can understand what it means. Okay, now I am moving to the SPSS part to explain how exactly we can do it in the software. Okay, so we are having the data set with us, but this data is not applicable in this file. I have to apply data set for independent sample t-test. So now I am going to apply this independent sample t-test. So this is my independent sample t-test. Okay, here the male and female, you can see we are having the data of male and female, and because there are two groups, one group is male group and second is female group, and I want to check that whether the job retention means on an average how much they spend, how much years they spend with the current company. So I want to know that whether the male stay more with the company or the female stay more with the company, right? So first example that I'm going to solve here, I want to check the null hypothesis whether the average retention of male is equal to average retention of female. So basically I am comparing the mean of male and mean of female. So this is independent group, this is also independent group. So we will check two steps, step number one, step number two. Here we check the leave-in test, whether it is fulfilled or not. And in second case, we apply the t-test. So this is the procedure of independent sample t-test. So let me apply this. Go to analyze, compare means, independent sample t-test, and the retention, the scale variable I am taking in the test variable, and gender I am taking in the grouping variable. Grouping variable means the samples, different independent samples. So I gave the male and female to 1 and 2. So where 1 means male and 2 means female. So I am deciding to give 1 to the male and 2 to the female. So I am giving these numbers to here. So genders is represented by number 1 and 2, and I am going to compare the retention of male employee and the retention of female employee. Just click OK. Now see carefully. So how to do step number 1, how to do step number 2. So I just write the whole command here. Number 1. Okay, let me use the pen. So in first case, the null hypothesis is the mean of male is equal to the mean of female. Okay. Now what is the answer? Mean of male is found to be 4.28. This is the value you can see. The mean of female is 5.64, and because it is a time, so it is a year. So we can see that female spend more time with the company as compared to male. Now I want to, can I say both are equal? Now the question is, can I say both are equal or both are different? So I will go for applying the test. So let me see the results. Yeah, so we are having the result here. Step number 1. Step 1. That leave-in test I have to check. Leave-in test. So leave-in test is giving you this result. Now the probability value of leave-in test is more than 0.05. It means assumption fulfilled. It means assumption fulfilled. Right. So assumption fulfilled. Then I will go to the step number 2. So there are two values of t. This is the first value if the assumption is fulfilled, and this is the value where assumption is not fulfilled. So this is assumption fulfilled, and this is assumption not fulfilled. But which value I should check here? Number 1. So step number 2 is t statistic is minus 2.525, which is greater than 1.96. The probability value is less than 0.05. It is exactly 0.29. So I can reject the null hypothesis. Reject the null hypothesis that the mean of male and female are equal. Right. So my conclusion is that on an average, female spent more time with the company. So let me clear it. So that you can see my assumption is fulfilled from here. And because my assumption is fulfilled, why fulfilled? Because significance value is more than 0.05. And if this value is not fulfilled, then I will check the lower value of t. And but here my assumption is fulfilled, so I have to check the upper value. So here t is more than 1.96. P value is less than 0.05. So I reject the assumption or null hypothesis that the mean of male is equal to the mean of female. So I'm rejecting the hypothesis here and concluding that females spent more time with the company. So this is independent sample t test. Now I'm applying this in another case. So here, now I'm going to apply the performance. Suppose I want to check whether the average performance of male is equal to average performance of female. So now I'm going to apply compare means, independent sample t-test, just see carefully, and I'm resetting it. Performance, which should come here, and gender should come here. In gender we are having two values, 1 and 2, male and female. and just click OK. So I have scale variables in the test variable, grouping variable in the gender, and now OK. So here, first of all, I have to check whether my assumption is fulfilled or not. So now you apply your knowledge. Can I say my assumption is fulfilled here or not? Okay. So now tell me, we have to check two steps. Step number one, can I say assumption is fulfilled? Yes, it is fulfilled because p value is more than 0.05. So if my assumption is fulfilled, which value should I see? Top upper value or my lower value? Right? If my assumption is fulfilled, which value I should check? Upper value or lower value? So now all of you are right. So I should check the upper value. So my upper value in case of t is less than 1.96 and probability value is 8.840. So what is my conclusion? Should I accept the null hypothesis? Should I reject the null hypothesis? Okay, so now you are saying that we should accept the null hypothesis. Yeah. Angel Joshi is writing the right statement. Rather than saying accept the null hypothesis, we should say we fail to reject the null hypothesis. We fail to reject the null hypothesis. No, so I'm writing this because Ramya is not right in the conclusion. So let me write here, because my null hypothesis is that average performance of male is equal to average performance of female. This is my null hypothesis. So first I go for the assumption. And I found that it is fulfilled. So because my assumption is fulfilled, so I check the upper value. And what is the upper value? T value is equal to 0.2 and probability value is 0.843. So it is less than 1.96. It is greater than 0.05. So my conclusion is that, so what is my conclusion? My conclusion is that null hypothesis cannot be rejected. Null hypothesis cannot be rejected. Right? So now this is, I hope you are clear on the independent sample t-test. If it is clear to you, say yes, so that I can move to the next test. Okay. So all of you are saying clear? Yes. And okay. Fine. When this assumption is fulfilled, the upper value and the lower value will be same. But if the assumption is not fulfilled, then there may be difference in the upper value and the lower value. Okay. Right. So I hope it is clear. And we should not go beyond this. This is the substitute of p-value. And because nowadays p-value is sufficient to conclude the answer, this method is very old method. This method is known as confidence interval method. We should not check this. So don't worry about that. This is only a substitute of the probability value method.